Hello everyone and welcome to Rebelway. My name is Andrew Sutherland and today we're going to be taking a look at really taking a control of your velocities, and we're going to use this technique to create some sort of abstract particle effect. In this case, we're running a particle simulation and we're manipulating the velocities using a curve. So we can essentially draw in anything we want. We could load in a logo and use the lines from whatever we draw or whatever we bring in to essentially update the velocities of our particles. And then we rasterize those particles into a volume, and we use that volume to then effect the velocities. And let's say in this example we're using an RBD sim, but of course you could use this in a smoke sim, you could use this in a water simulation, so I think this is quite a powerful technique. And I think this is the best way to sort of manipulate the velocities with a curve or a logo. So I'm going to show you how that is built from scratch, and then we're going to dive into Gavin's scene. Gavin created the overall scene that we're going to take a look at, and he's just got a few more variations. So, and you see in his example, we're going to change from a logo to a shape to some text or anything like that. Without further ado, let's jump into Houdini and take a look. So first things first is we're going to put down a geometry because we need to create some data. And we're going to first just put down a circle. So as you can see here, we've got a circle, and let's maybe just up our divisions. Cool. And let's transform this. So what I want, so let's make this an open arc. So we're just dealing with this line here. And what I want to do is I want to animate this the circle. So I'm going to just type in a sine function here, and this is going to oscillate between 0 and 1 in this case. So I'm just going to put $f, so it's going to happen over time. And let's take a look at what this gives us. So you can see now our sphere is oscillating, and let's just tick on this so we can see this in real time. You can see this is moving pretty slowly, so we can increase the speed maybe by timesing this by 5. So we've got this cool animated circle here. We take a look at our points. Let's just put down a resample. And then let's put down a polyframe so we can compute the tangent of the circle. So what this is going to do, if we come over here to tangent, and let's actually just store the tangent in the velocity. And if we take a look now at the velocities, or let's click on here, we can see that this is looking like kind of like a Catherine wheel. And this is exactly what we want. We want these sort of spinning velocities. And we're just using, we're going to use the tangent, but we're going to save the tangent as the V, which is essentially creating a velocity in the direction of our tangent. From here, we can just put down a wrangle, and I just want to increase our velocity. So here we can just say V at V times equal 5. And as you can see, now we've got, even more velocity. And great. From there, we can just put down a null. And this is what we're going to use to direct our velocities. But in this case, we're going to direct our velocities initially with a pop simulation. So we're going to put down a pop network. And we dive inside and we can see we've got our basic setup. But we're going to initially give this a grid of points. So let's just put down a grid. And let's scatter some points. Let's make it 12,000. So we've got these points, and we're going to feed this into our first input. So coming into our pop network, and we come over to our pop source, We're going to set this to all points. So this is going to bring in our data from our first context geometry. So if we take a look at this now, and let's just set our life expectancy to something very low. So we've got our data coming in and we're not really seeing anything because we have no forces. So let's put down a gravity just to make sure that this is coming in. And as you can see, we have a pop sim. Nothing fancy at all. And what we want to do is actually not use a gravity. We're going to use the data that we prepared. So what we want to do is we want to update the velocity here, but not with the gravity node. We actually want to bring in our circle. So we want to take a look at this circle, and we want to get these particles to be attracted to this and also to swirl around with that tangent velocity that we prepared. So, coming over to our tangent, we want this to swirl around, and as this shrinks and grows, we want our particles to be attracted to this. So we're going to use a node inside of VOP called PC Open, and what this is going to do is this is going to open up a point cloud and it's going to look at our points. And really, if you've ever used an attribute transfer, it's very similar to that. So let me just quickly illustrate something. So I'm going to have a grid. Let's put a color on our grid. Let's make this black, and then let's put a sphere, or we can actually just take our circle here. We can put a color on our circle. Let's make this red. And what we want to do is put down an attribute transfer and transfer this color to this. So you can see here, it's just immediately gone from black to red. And that is because our conditions are a bit extreme. So if we bring down this radius, let's increase our divisions here. And as you can see, if I start playing with this distance threshold, this is basically looking up these points and saying, how far are you from this circle? And if it's within this radius, then we're transferring this color. And we're going to do something similar in a VOP here, and we're going to be saying, hey, like which of these points is close to this circle? And we're going to basically attract the points to this circle and inherit that velocity by looking at where are the points, get the direction of those points, and add the velocity from a pop simulation, from the velocity from that tangent, and the velocity of the sphere shrinking and growing, and then add all those velocities together, and then we're going to export that as our velocity that we're going to rasterize. So diving to the pop network, the first thing that we're going to need, because our particles are going to move pretty quickly, is a pop speed limit, just to make sure that our speed is under control. And let's set this to something like 3. And here we're going to put down a pop solver. And this is going to update our velocities. So the first thing we need is a point VOP. Let's put this in here. So here we want to take the data from our DOP network and we want to merge in our circle. So we can put down an object merge here, feed that in, and let's just take this null and pop this in here. So this is our second input and this is our first input. If we dive inside this VOP here, we can see this is the velocity we need to update. So let's compute the direction our particles need to move to. So we need to move towards that circle. So we're going to put down that node PC open, and we want the position of our DOP network, and we want our second input, which is our circle. So next thing we want to query is the position of our second input, and we can do that by subtracting this position from the position, so the position of our circle from the position of our points, and we just put down a subtract. If we feed this into the V, so you can see now that we are moving the points in the direction of our circle. Sorry, we need to put it here. Cool. So you can see we've got the direction of our particles. Great, so now let's just add that to the velocity of our second input, because that's got that tangent velocity plus it's moving back and forth. So let's put that, we can just actually copy this and we can query the V, the velocity. Let's just normalize this and let's add this to our other velocity and let's see what this gives us. Cool, so I'm just jumping back out here to reset my simulation. And we should be getting our velocities, but we're not, and I think that's because we need to increase our radius. So if we come over to this PC find, and let's increase our radius to 5. Jump back and reset. Now we can see we're updating those velocities. So this is pretty cool. Let's increase this to 20. Reset. We can also add the velocity from our initial points. Although I don't think they have any, but you know, in case we do, we might want to just include this. Cool. Okay, cool. So another thing that we can do is we could read in a logo. So let's put down a trace node, and I have a black and white copy of the Rebel Way logo. And let's put down a dissolve node, so we just have the outlines like this. Let's put down an add node, so we can connect all those points. Let's copy our polyframe with our tangent as V. Okay. Let's multiply down our velocities now. Let's take a look. Let's transform this up. Let's see our circle. Let's rotate this down. And then let's feed this into our system. Cool. So as you can see, we now have these velocities moving around our logo, which I think is pretty cool. So with that out the way, let's jump into Gavin's file and we can take a look at how this was used inside a RBD sim. But essentially what we're going to do is we're just going to create a volume version of this and just feed this in with a volume advect into whatever simulation we want. So let's take a look at that now. So we're in Gavin Thin, and if we take a look here, we can see that we've got our logo. Here we've got a sort of tick, so you can just come over to this curve and you can just draw. Here we've got 4 circles. And here we've got our original circle, but we've also got an edit on it, and then we're blend shaping. So you can see we have something like this. So just some variation really in our shapes. And we're just going to go into this pop network that we set up earlier. And as you can see, this is the same setup that we had earlier, except if we dive inside, you can see we've just got a few more of these. So these are just, we're reading in different, we're just reading in those 4 different nulls. So this will be the first one, which is our sphere. This is our 4 spheres. This is our drawing. And this is our Rebel Way logo. And if we dive inside this VOP, we'll see we've just got, this is for the first one, this is for the second one, and this is for the third one, and all we're doing is mixing with a mix node to change from this one to this one, and from this one to this one. So it really is exactly what we've done before. If I were to delete this, this is exactly our little setup that we used. But of course, because we've got more inputs, we need these, as you can see here. And I believe there's just a little bit of variation possibly on our PC find. So here we're changing the search radius and the number of points, the search radius and the number of points, search radius and the number of points. Cool. So if we just cache this out to disk. So I've just run a flipbook here, and you can see this is our result. You can see it's jittering a bit, and that's because our birth rate is 2 and we're actually emitting on every second frame. But this is not going to be a problem once we rasterize this into a velocity and we run a RBD sim. You're not going to see that sort of stepping. So if we take a look at that, you can see over here we're just emitting every second frame. So if we come on frame 1, it's emitting, then it's off, then it's on, and it's off. So that's where that sort of jittering is coming from. And also our birth life expectancy is just 2. So these are being birthed and dying within the first 2 frames. And this is just going to give us this really cool velocity. So I've got that cached. And from here, what we're going to do is we're going to take this grid and we're going to scatter some points again. And we're going to create an attribute just temporarily, but it's going to have a value of 0. So it's just a placeholder really. And if we jump down here, you can see we're making some copies of this. So this is being copied. So we've got 4 copies and just transferred down a bit. And here we have our original sim. We're deleting everything but the velocity. We're deleting our groups. And we're transferring this velocity onto these points here. And here we're doing the same thing. We've got points, we're scattering, we're copying down, and we can visualize our trails with this volume visualization. But of course, we need to actually rasterize these attributes. So here we're creating a, we're converting these particles into volume really. So as you can see here, the velocity volumes never look great, but if we put down a volume visualization, now we can see our trails and they're looking really, really cool. So let's just flipbook this. So here we can see our velocity trails. I think this looks pretty cool and it runs through all our shapes. And this is a volume, of course. So from here, we can just put this out, a null out for to read an LV. Here we've got a box. We're going to create a density. And this is going to be our velocity and our density, as you can see here. This is just an option for rendering with the ground. Didn't end up using this because I went for a different idea. But if we come over here, we can see we're extruding this. So here's our grid, extruding this down, creating a whole bunch of points within that volume. We're doing the same thing here, and we're going to use this as our bounce. So here we're just basically like creating a frame, and for our collisions we want a VDB version and we want a geo version. So this is our wall VDB SDF and this is our geo. If we come over to our points and we randomize the normal, that just means that because we're actually going to copy some blocks to this, and we want that orientation to be randomized. We're also going to give these an ID based on their point number, and we're setting a group. We're just going to group these top half, and we're going to split the top half on this side and the bottom half here. So here we're setting a p scale, so this is going to have a random p scale between 0.05 and 0.1. And if we take a look at that, we can see we've now got all these boxes copied here. And like I said, we are where we're randomizing that. Here we go, randomizing that normal. And without that, you can see they're all uniform. So that's why we're randomizing the N. And if we come over here, we're going to use some randomization to select some random points. So here you can see we're just selecting a few. And here we're fitting the range between 0.1 and 0.25. And on here we're giving it a 0.0 and 0.06. So these are going to be very small, as you can see here. And these are going to be our bigger blocks. And we merge these all together. And now we're going to have our first two layers and then this bottom layer, which is here. We're going to merge those all together, and then we're going to assemble these and tick on create pack primitives, because that's what we need to pass over to our RBD system. We always need to pack the primitives. So from here, we're just grouping those top points again. And then we can say these top points are going to be active and these bottom points are going to be inactive. So here we're just initializing it, active and animated. And then you can see here we're running over that group 1 and we're setting those to active. Just in case this isn't clear, active means that the RBD system can take over and move those points, and inactive, they're just going to remain static. So these bottom points are not going to be affected by RBD Sim. These bottom blocks, I should say. So these bottom blocks, I should say, are not going to be affected by Sim, but these top ones, the active within that group that we see here, these are going to be part of the simulation. So we've got a null, and this is going to be our source, and we can put down a dot network. So here's our RBD packed object, and you can see we're bringing in that source, and we're bringing in animated geometry, and we want to affect the active. So as you can see here, these are all our settings for our RBD Sim. Pretty straightforward actually. And here we've got some collisions, so we're going to bring in the wall. We've got a ground plane, our solver, and the important thing is our pop advect by volumes. So you can see we're bringing in that, we called it VV, and that's that volume that is, we can take a look at it here, this VV. Here, this is our volume. Like I said, Houdini doesn't like to visualize the velocities very well, so we can take a look at what they're doing with this point trail. Cool, so all we need to do is run the sim, and as you can see, our active points are now being affected by that velocity. And this is looking really, really cool. So we could put down a particle fluid surface, set this to particles, and visualize the velocity. So if we just cache these as points now, we can see we've got this really amazing simulation that with like absolute control over our particles. And I think this is a really, really cool technique just to control particles or simulations. You can use this for so many different things. So obviously, let's just take a look at this. You can see we bring in the DOP network, we bring in the object, so that is this node here. And we've got this as create points to represent geometry. So we're only caching the points because they have this name attribute, and our points, when we assembled them, we said here and we said create name attribute and create packed primitives, so they can be linked back together. So if we do that based on the name here, you can see that now our boxes are going to move with our cached points like we do for any old RBD sim. So here we're just going to unpack those boxes, and here we're computing this length or this velocity, and we're storing it as VL based on the length of the velocity. And we can just put down a color, and you can see we can fit that between 0 and 10, which is exactly what we're doing with this node here. You can see I'm visualizing the particles as velocity. This is just another way of doing it. We're just computing the length of velocity. And we also got this emission. If we wanted to make some of these glowing, we could this emission attribute, and that's fitting the velocity between we're taking the velocity between 0.3 and 15, and we're fitting it to 0 and 5. So we've got two attributes there. I just put down a color, and I'm reading in that QL, and then you can see I've got these colors copied on here. You could of course just come and play with these, see what different looks you can get just with the Houdini presets. I think this is pretty cool. From there, I was just transforming this up for rendering, deleting everything but the color, the position, and the velocity. Trailing these just to recompute the velocity. Always after doing a simulation, I always just like to post compute. And I packed these once again because I want to render this efficiently within Solaris. So I put down a pack and I just cache this out to disk. As you can see, I lost that color because I'm just reading this from my pre-existing cache. So that is that. I also put Tommy in here just as a scale reference. I wanted to look like he's in some sort of gallery looking at this artwork. Cool. So next up, we just need to render this. So I've just made a few tweaks for our render, and we're going to take a look at how I rendered this. So first things first is I just changed the colors. So if we come in here, you can see I've put down this color node. We took a look at this, and I'm just picking these colors actually based off a painting. So if I double click here, you can come in here and you can load in your own picture, or you could even add a URL. So here I've got an HDRI that I created, and I'm going to base these colors off this painting. So just by coming in, clicking here, you can see you can sample all the colors in this painting. One thing I should mention is that this painting is in the correct color space, so it's this is exported from Nuke as linear. And I'm just picking these colors, and so this is what we've got here. Change this back to my blue color. And from there, I think we really took a look at this, but I'm deleting everything but I'll CD, P, and V. I'm not using the submission, trailing those particles, caching this packed out to disk. And over here, I was experimenting with actually, I shot some footage and I wanted to place this in the scene and with the camera track, but this is going to take me far too long in comp to finish off in time. So we can ignore that, but I just transitioned this into place based on my scene. You guys don't need to worry about that. You know, it's just basically a matching a size to my a box that I put down as a reference. It's nothing special. You can ignore this. Just, you know, in your case, just cache this out and come over to render. So here I've got this cached, and I've cached it as a packed primitive. And that way we can read this in from disk, and it's going to render really, really quickly. I'm just using a geometry sequence node to do that. Inside here, I've got this frame, which is literally just 2 boxes, and you know, the middle being booleaned out. And from there, we want to create some materials. So this is our box, and as you can see here, I'm reading in the color, and that's being multiplied actually with a texture I got from Grayscale Gorilla. This is a colorful plastics, and I'm just feeding in that, and I've also got some roughness, so again a texture from Grayscale Gorilla, and I believe this is the normal, and that's going into this tangent and out as geometry. Cool. Nothing crazy. The frame is literally just reading in the color, and I've got a bit of roughness. A wall, which I'm not rendering, and we just need to assign those materials. So here I've come over to the box and the frame, so I'm pulling in that mesh and that mesh, and I'm assigning my materials here by just dragging and dropping there. This merge is not merging anything in, and then I just have a couple lights. So on this light, this is set to rectangle, and the way I set it up is I came over to the specular and I placed the specular by actually clicking on the artwork, and you can see you can place the lights nicely this way. This is how I like to light my scenes. So I'm just going to bring that back. You can place your specular, you can place your shadows, and it's got a fixed distance set here. Again, I've got my environment light, which is just an HDRI that I created. You can get your HDRI from HDRI Haven, and here's a second light. I call it character light, but you know, I was just same thing I did with this first one, just placing the diffuse and the specular here. I called this character light because I was playing with an idea of putting a character here, but in the end I ended up just, you know, doing the same thing I did with this artwork light, just placing the specular. And on all of these lights I've got created a tag, so you can see this is called character light, this one is called environment light, and this one is called art light, and that's just so that I can have some control in compositing. From there we're going to set our render settings, and I wanted some motion blur, so I've got that enabled, and cusp angle, and I think that's about it. From there I was importing our cameras, which I didn't end up using. Again, this is me editing the light, because I actually came here and I looked through this light here and locked it in place, and I just was positioning because I was just working on angling the shadows correctly. And that's it. And then we're going to use this one to render, and you can see what those render settings. I'm looking at my camera 2, which is this camera, and these are all my settings. We can maybe introduce some subsurface if you want. Our limits, motion blur. And that is it for the render. I hope you guys enjoyed this. I enjoyed making it, so I'll see you guys in the next tutorial. Bye.